Gas Law Stoichiometry Worksheet. In this worksheet, you'll be using both stoichiometry and the ideal gas law to solve for how much of a substance is going to be used or created in a reaction. So the first thing it'll do is ask you to balance the equation. So let's go ahead and do this first one together. I see here that I have two CL's on the left, but I only have one CL on the right, so I'm going to put a 2 here. That also gives me 2 NAs, so I need to put a 2 on the left, so I have 2 NAs on the left, 2 on the right, 2 CL's on the left, and 2 on the right, which leaves me with a 1 in this blank, because I don't need to change how many Cl2s I have. So I've balanced it. Then it asks me what volume of chlorine gas measured at STP, so I'm still at standard temperature and pressure, is necessary for the complete reaction of 4.81 grams of sodium metal. So here's our sodium metal. Sodium by itself is a metal. And so I'm going to do a stoichiometry problem right here to solve for the volume of chlorine gas. Now since this is at STP, I can use 22.4 liters for 1 mole of chlorine gas, which is Cl2. So there's nothing special that has to be done here. But when you get down to number 2, you will have to use PV equals nRT because you have a different temperature and different number of atmospheres, a different pressure than you would have at STP. So in this one, when we balance this, we have 3 C's, so we need 3 C's. H8, so we need 8 H's over here, so I need to do 2 times 4. And then here that gives me 6 O's, and another 4 O's gives me a total of 10 oxygens, so I need a 5 here to make 10 oxygens. And that one's balanced. So I have 3 C's, 8 H's, 8 H's, and 10 total O's on each side. So once that's balanced, then I can do my stoichiometry. It gives me 5.53 grams of propane, and it tells me, pardon me, it tells me here in this equation, it doesn't say which one is propane, but I know this is oxygen, I know this is carbon dioxide, and I know H2O is water, which leaves this one to be propane. So I have 5.53 grams of propane. That's what I'm starting with. And I'm going to do the same thing I always do. I'm going to change that into moles. So 1 mole of propane would be how many grams of propane? Now remember to figure out, since I have grams of propane here, I need grams of propane here. And to figure out how many grams are in 1 mole, I just add up 3 C's and 8 H's. So you'll do that here, plug in that number right there when you add up 3 C's and 8 H's, and then you have one more step that you need to do where you're going to compare your moles to moles from the balanced equation. So I have moles of C3H8 here, and in this equation I have 1 mole of C3H8, so 1 mole C3H8, and then it asks me what volume of oxygen gas. So this one is oxygen gas. This has oxygen in it, this has oxygen in it, but this is water, this is carbon dioxide, so here's just my oxygen gas, and I have 5 moles of it. Now normally, I would take one more step here and figure out how many liters of oxygen I end up with. However, since I'm not at STP, I can't say 1 mole of O2 is 22.4 liters, because it won't be with this change in temperature and pressure. So I'm going to do the math out and solve. So I'll do this times this times this, divided by this times this. All right, and whatever I get for that answer will give me N for my number of moles. And then remember, for your PV equals nRT, your N is your number of moles. And that's what you're going to be solving for here, is how many moles of O2. Because your grams of C3H8 will cancel out, your moles of C3H8 cancel out, and you're left with moles of O2. So you will plug in the pressure that it gives you, the number of moles you just solved for, R, which is your ideal gas constant, and the temperature. Don't forget to change this to Kelvin by adding 273, and plug that in for T, and then you will solve for volume. because it asks what volume of oxygen. So whatever you get for this answer, plug that in for N, plug in your pressure, your number of moles that you just got, your R, which is 0.0821, always, and your temperature, which will be 25 plus 273, and then solve for that volume of oxygen. You're going to do the rest of these the same way, get to where you have solved for your moles of the substance, and then plug that number of moles into PV equals nRT and solve for volume. If you do have problems with any of these, please make sure you come ask.